Good morning students. Vikas Global Institutions, Zengareddigudam. In chemistry, last class I was discussed about the different form of energies. Different form of energies. Different form of energies, and among this one is the heat and second one internal energy. Second one internal energy. Second one internal energy. First one heat. What is the heat? It is a form of energy. It is transferred from one system to another system. Difference in the temperature. Difference in temperature. What is the difference in temperature? That is a delta H. Sorry, delta T. Difference in temperature. That is a delta T. Delta T. Here, so what is meant by heat? It is a form of the energy. It is a form of the energy. The heat flow from one system to another system. Difference in temperature is called heat. Okay. It gives some units of the heat. That is the units. What are the units of the heats? Generally, it measured in calories. Generally, it measured in calories, and also joules. Generally expressed in joules. So 1 calorie is equal to 1.48 joules. Last class lo cheptunnam manam. So heat is the transfer of energy. It is another form of energy. Heat flow from one system to another system in difference in temperature, and units are calories, generally measured in calories and expressed as a joules. So 1 calorie is equal to 4.18 joules. 4.18 joules. 4.18 joules. And the heat is the state function or path function. It is a path function. Why? It is the path function. Why it is called path function? Here the heat does not depends upon the initial and final state of the system. It depends upon the heat depends upon the only path. So heat is the path function. So in objective point of view, you give one question, that is the heat is a path or state function. It is a path function. Why it is called path function? It does not depends upon the initial and final state of the system. Does not depends upon the state of the system. It depends upon the path. So it is a path function. It is a path function. Clear, Nana? Okay. Okay, Nana. And next one, later I will discuss about the internal energy. Next one, internal energy. So what is the internal energy? Okay, what is the internal energy? It is also known as change in the thermodynamic energy. It is also known as change in thermodynamic energy. Change in thermodynamic, it is also known as change in thermodynamic energy. It is a sum of the all types of energies like potential and kinetic energies of the constant particles of at a given temperature is called internal energy. Simply write the internal energy is a sum of the energies like potential and kinetic energies, So finally we write how to write the internal energy. It is a sum of the all types of potential and kinetic energies of constant particles at the given temperature is called internal energy. Internal energy. Clear, Nana? So it is the last class internal energy. Already cheptunnam internal energy gurinchi. It is impossible to determine it is represent E or U. Dini E kani lepothe U to kani represent chestam. It is represented by the E or U. Okay. So it is impossible to determine the absolute value of U. It is impossible to determine the absolute value of U. It measures the change in the internal energy. We can determine the change in the internal energy by using first law of thermodynamics. Okay, Nana? It is a state function. It is a state function and extensive property. It is a state function, extensive property. Why it is called state function, extensive property? Here the internal energy depends upon the initial and final states. How? It is a delta U means U final minus U initial. U final minus U initial. So here the internal energy depends upon the state of the system, state of the system and also depends upon the initial and final state of the system. So it is a called state function. It depends upon the total amount of the substance. So it is a called, here means internal energy is also called extensive property. Finally, internal energy is the state function and extensive property. Okay, the heat content of system at constant volume. The heat content of the system at constant volume, we write the delta U is equal to QV. It is the heat content, internal energy is the heat content of system at constant volume. That is the internal energy. Later, that is the enthalpy. Last class is the third one is the enthalpy. Enthalpy. So it is indicated by the H. It is denoted by the, it is represented by the H. So what is the enthalpy? It is a measurement. Enthalpy is a measurement. It measures the total heat content present in the system. Okay, enthalpy is the measurement. It measures the total heat content present in the system is called enthalpy. The enthalpy according to classes. According to classes give the one formula about the enthalpy. Enthalpy ki classes and scientists oka formula ichinaru, that is the H is equal to E plus PV. E plus PV. We also write the H is equal to U plus PV. Anyone we write the H is equal to E plus PV or H is equal to U plus PV. Okay, what is the enthalpy? It is a measurement. It measures the total heat content present in the system at constant volume, at constant pressure. At constant pressure and temperature is called enthalpy. So according to classes, enthalpy is the H is equal to E plus PV or H is equal to U plus PV. It is the state function. It is the state function and extensive property. Why it is called state function extensive property? It is a state function. It depends upon enthalpy depends upon the initial and final state and also depends upon the state of the system. It is called state function. And why is it called extensive property? Here the enthalpy depends upon the total amount of the substance. So it is called extensive property. Finally, enthalpy is the state function and extensive property. State function and extensive property. The change in the enthalpy at constant volume, delta H is equal to delta U plus P delta V. At constant pressure, the change in enthalpy, delta H is equal to delta U plus P delta V at constant. The change in enthalpy at constant pressure is equal to delta H is equal to delta U plus P delta V. It is impossible to determine the absolute value of the enthalpy. It determines the change in the enthalpy. ఇక్కడ మనం డైరెక్ట్గా H వాల్యూని ఫైండ్ అవుట్ చేయలేం. You find out the enthalpy change, that is a delta H. This is the last class, transformation, different form of the energies. Okay, one is the heat and second one is internal energy and third one is the enthalpy. Here heat is represented by the Q. When heat is absorbed, that is the positive sign of conventions kuda cheppukunnam. Sign of Q. When it is positive, when it is negative. When heat is absorbed, that is the positive sign. When heat is released, when heat is absorbed by the system from the surroundings, that is a positive Q. Here the heat represents the small q or capital Q. The heat absorbed by the system from the surroundings, that is called positive Q, positive sign. When heat is released to the surroundings, that is the negative sign. That is sign conventions of the heat. That is the internal energy, that is the enthalpy. Now some objective bits on these three topics: heat, internal energy and enthalpy. Okay, Nana? Okay, some objective bits on the different form of the energies: heat, enthalpy, internal energy. Number 1, the change in internal energy, the change in internal energy, the change in internal energy of a system depends on number 1, option 1, initial and final state of the system, initial and final state of the system, initial and final state of system. Number 2, the path if reversible, Number 3, the path if irreversible. Number 4, initial and final state and also on the path, initial and final and also on path. Question చూడండి నాన్న. Question is, the change in internal energy of a system depends on, simply the system depends on the initial internal energy అంటున్నాడు, especially internal energy of the system depends on the number 1, initial and final state of the system, number 2, the path if reversible, the path if irreversible, initial and final and also on path అంటున్నాడు. So guess internal energy. What is internal energy? It is sum of the potential, it is sum of the all types of energies అని చెప్పుకోండి. But mainly the internal energy, it is impossible to determine the absolute value of the internal energy. It measures the change in the enthalpy. It is a state function. What is meant by state function? It depends upon the initial and final state. Here the internal energy of the system depends upon, here the initial internal energy of the system mainly depends upon, దీని మీద డిపెండ్ అవుతుంది అంటున్నాడు internal energy. So that is we guess the answer, that is the initial and final state of the system. అవునా కదా? Yes or no? Yes. The change in the internal energy of the system depends upon the initial and final state of the system. Clear? And next one. The correct expression among the following. Number 1, E is equal to H plus PV. Number 2, H is equal to E plus PV. Number 3, H is equal to E minus PV. Number 4, P is equal to E plus HV. ఇప్పుడే మనం చెప్పుకున్నాం నన్న ఈ టాపిక్ గురించి. The correct representation among the following. The correct expression among the following. So E is equal to H plus PV, H is equal to E plus PV, H is equal to E minus PV, and P is equal to H plus P is equal to E plus HV. So we know the enthalpy. What is the enthalpy? What is the enthalpy? It is the measurement. It measures the total heat content present in the system. That is the enthalpy. So clashes give the one formula about the enthalpy. What is the formula of the clashes? That is the H is equal to E plus PV. It is given by the clashes enthalpy formula. Enthalpy formula given by the clashes, that is H is equal to E plus PV or H is equal to U plus PV. You can write any one. So among these 4 options, which one is the correct? The H is equal to H plus PV, and second one H is equal to E plus PV. So this is the correct answer, that is the 2. The correct expression among the following, that is the H is equal to E plus PV. Okay, Nana? And next one. Enthalpy change during enthalpy change during a reaction. A reaction does not depend upon. Does not depend upon. That is the question. Options. Number one, conditions of a reaction. Conditions of a reaction. Number two, initial and final concentration. Initial and final concentration. Number three, physical states of reactant and products. Physical states of reactants and products. Physical states of reactant and products. Number four, number of steps in the reaction. Number of steps in the reaction. They give the four options. Question is, enthalpy change during a reaction does not depend upon the. Here the number one, conditions of the reaction. Number two, initial and final concentration. Number three, physical state of reactant products. Number four, number of steps in the reaction. So we know the enthalpy, which here the three options are related to enthalpy, and but fourth one is the reaction does not depend upon the. So guess the one, first one, conditions of the reaction. S. Initial and final concentration. S. Number three, physical state of the reactant products. S. Number four, number of steps in the reaction. It's the wrong answer. So here the correct option is number four. Number of steps in the system. Sorry, number of the steps in the reaction. Enthalpy change during a reaction does not depend upon the number of steps in the reaction. There is no depends upon the reactions. Number of steps. Any one enthalpy or internal energy or heat, any one does not depend upon the number of steps of the reaction. So here the enthalpy change during a reaction does not depend upon the number of steps in the reaction. Okay, next one. Next one. Heat change in a chemical reaction. Heat change in a chemical reaction. Heat change in a chemical reaction at constant temperature and pressure. At constant temperature and pressure. At constant temperature and pressure, temperature is called number one, entropy. Number two, enthalpy. Number three, internal energy. Number four, free energy. Free energy. Guess the answer? So heat change in a chemical reaction. Heat change in a chemical reaction at constant temperature and pressure is called Chepandana. So heat change in a chemical reaction at constant temperature and pressure is called entropy, enthalpy, internal energy, free energy. So we know the enthalpy. What is enthalpy? What is enthalpy? It is indicated by the H. What is enthalpy? It is the total heat content. It is one of the measurement. It measures the total heat content present in the system at constant temperature and pressure. We discussed 10 minutes back. Now what is enthalpy? It is a measurement. It measures the total. It is a measurement. It measures the total heat content present in the system at constant temperature and pressure. That is called enthalpy. Among these four options, the heat change in a chemical reaction at constant temperature and pressure is called enthalpy. That is the second one. Okay, next one. The heat change associated with the heat change associated with reaction at constant volume is due to the difference in which property of the reactants and the products. Number 1, internal energy. Number 2, enthalpy. Number 3, heat capacity. Number 4, free energy. చూడండి అన్న, the heat change associated with reaction at constant volume is due to the difference in which property of the reactants and the products. So the heat change associated with the reaction at constant volume, that is the internal energy. So why we know the internal energy? It is represented by the URE. I give the one point in the internal energy. What is the internal energy? Internal energy ఒక పాయింట్ చెప్పుకున్నాను. ఆ పాయింట్ ఏంటంటే it is the heat content at constant volume. Based on that point, the heat change associated with the reaction at constant volume, the heat change associated with that constant volume is due to the difference in which property of the reactant products is the internal energy. Guess the point? Here the internal energy, it is the heat content of system at constant volume, that is called internal energy. Clear Nana? And next one, the standard enthalpy. Number 1, next one, the standard enthalpy is 0 for the substance. Number 1, graphite. Number 2, diamond. Number 3, carbon dioxide. Number 4, ozone. Okay Nana, the standard enthalpy is 0 for the substance. ఈ స్టాండర్డ్ ఎంథాల్ఫీ అనేది ఏ సబ్స్టెన్స్కి 0 అవుతుంది. గ్రాఫైట్ C, కార్బన్ కా, diamond C and carbon dioxide, ozone. Here the standard enthalpy of 0 for the substance is the graphite. Why? The graphite is compared with the graphite and diamond, the graphite is very strong, very less intermolecular forces. So the standard enthalpy is 0 for the substance, that is the graphite. Okay Nana? Thank you. Tomorrow I will continue. Tomorrow I will discuss about the work done. What is the work done in the reversible? What is the work done in the irreversible? On the system ఎలా ఉంటుంది, by the system ఎలా ఉంటుంది, work done on the system, work done by the system. Tomorrow I will continue. Thank you students.